Here we are on number 10 with our area review. Determine the area of a trapezoid. So remember the area is B1 plus B2 divided by 2, and all of that is multiplied by the height. So we don't know the height, and we also don't know one of the bases. So if we draw on the height here, it's the same as that one. Conveniently, this is a 45, 45, 90 triangle. And so we can set up our proportion. 1 over x equals root 2 over 8, and we can cross multiply. X root 2 equals 8. X equals 8 over root 2. Rationalize your denominator. So I have 8 root 2 over root 4, which is 2, which means 4 root 2 is that piece. And 4 root 2 is that piece, because it is an isosceles triangle. This is 7 root 2. So now you have all your pieces that you need. You have your B1, which we can say is 7 root 2. Your B2, which is 7 root 2 plus 4 root 2, which makes 11 root 2. And then your height, which is 4 root 2. So 7 root 2 plus 11 root 2 over 2 multiplied by the height, which is 4 root 2. Well, 7 plus 11 is 18 root 2 over 2 multiplied by 4 root 2. And then we can reduce that, because 8 divided by 2 is 9, so 9 root 2 multiplied by 4 root 2. So we multiply 9 and 4, and that makes 36. And then root 2 times root 2 is root 4, which is 2. 36 times 2 is 72. A rectangle's length is 4 less than 3 times its width. Find the perimeter of the rectangle if the area is 384. Here's my rectangle. The length is 4 less than 3 times the width. So 3, if that's the width, then 3 times, and we have 4 less than. So remember, area is base times height. So x and 3x minus 4 equals 384. If I can figure out x, then I can figure out the perimeter. This is x squared minus 4x. I'll go ahead and subtract the 384 over. Now, this might take a little bit of guessing and checking on our part to figure out numbers that multiply to 384, but add up to 4. And remember, this is 3x. I wrote that wrong. Okay, so you can mark or you can guess and check, whichever you prefer to do. In this case, I would say that marfing might actually be faster instead of guessing and checking, although you do know that this has to be a 3x and that has to be an x, because 3x times x is 3x squared. So if I think about 384, numbers that multiply to give me 384. I'm trying to get to numbers that are 4 apart. That's the goal. So if I do 384 divided by 4, I get 96 and 4. So like if I put the 4 here, I would do 3 times 4, which is 12, which is not 4 apart. So that's probably not going to work. So let's do 384, and I know 5 doesn't work. What about 6? 64 and 6. So again, I would have to put the 64 here because I'm going for numbers that are 4 apart. So I put the 6 here. That makes 6 times 3, which is 18, which is still not 4 apart. So that's not going to work. Let's try 384. I don't think divides by 7. So 384 divided by 8 is 48. So 8 times 3 is 32. or 24, and 24 and 48 are not 4 apart, so that's not going to work. It doesn't divide by 10. Let's try 12. So 384 divided by 12 is 32. So I put the 12 here and the 32 there. 3 times 12 is 36, and 36 and 32 are 4 apart, so that's what I want. So I'll put the 12 here and the 32 there. Double check it just to make sure. Those are 4 apart. I need since it's a -4, I need the 36 to be negative, which means I need the 12 to be negative. So my two answers for x would be x equals positive 12 and x equals 32 over 3. And it would be negative 32 over 3. Well, negative 32 over 3 does not work for my situation because I have a negative side measure, which is not cool. So now that I know that, I can use the 12 to figure out my perimeter. So that means that this side is 12. This side is 12. Then I have to do 3 times 12 minus 4. So that's 32 and 32. So when I add up 12 and 12 and 32 and 32, I get 88 for my perimeter. Great. Now we have this goofy shape. Determine the area of the shaded region. So I want this piece and then this piece right here. So again, let's break it down into smaller parts. This is a triangle. It is an isosceles triangle. But I don't know any angle measures or the bottom length. So I'm going to have to do some thinking here. So in here I've got an equilateral triangle, which means all the angles are 60. And that's a 90. So that's 30. And this big angle on the top would be 120, and it cuts it in half. Oh, so conveniently I have a 30, 60, 90 triangle. So that means that the height of this triangle is half, because it's the short side. So that's 3. And then that means this is 3 root 3, which means that is 3 root 3. So the area of this triangle right here would be 6 root 3 times 3 divided by 2. I get 3, so 3 root 3 times 3, which is 9 root 3 for the area of that piece. Cool. So now let's think about the area of this piece. It might be hard to tell, but this piece, this big piece, is a sector. So if I take that sector and find the area of that, and then I take out the equilateral triangle, I will get that little sliver on the top. So I know that that's 60 because it's an equilateral triangle on the inside. And the radius of the sector is 6. And then I want to take out the equilateral triangle with sides measuring 6. So first, find our fraction out of our circle. So 60 out of 360, which is 1/6. And then multiply that by the area of my circle, which is pi 6 squared. So that's 36 pi over 6, because remember this piece is all over 1, which means the area of the sector is 6 pi. Now I got to take out the area of the equilateral triangle. So that's 60, that's 30, which means this part is 3, and that part is 3 root 3. So this time my base is 6, my height is 3 root 3, and I got to divide that by 2. 6 times 3 is 18, root 3 over 2, which means 9 root 3. So this is interesting. The area of this triangle, this equilateral triangle, is the same as this isosceles triangle. So I have to take out the 9 root 3 to find the area of just this goofy part right here. But then I got to add on the 9 root 3 for my original. So my answer is just 6 pi. Convenient how life works out sometimes. Now let's do the next one, number 13, with the rectangle. On the area and perimeter of the rectangle, unfortunately, I don't know any sides, but that's okay. Because look at that. It's a 30, that's a 90 because we know it's a rectangle, and it's a 60. So if you remember, the short side is always half of the hypotenuse, so that's 7. Short side's always opposite the 30 as well. That means this is 7 root 3. So my area is base times height, which is 7 times 7 root 3. So 49 root 3. My perimeter, I got to add up all the sides. So I've got 7 and 7, which makes 14. And then I got 7 root 3 and 7 root 3, which is 14 root 3. And I can't do anything else with that. So those are my two answers. Find the area and perimeter of a parallelogram. Now note, these little slashies are a little light, but it's also saying that all the sides are the same, which means that this parallelogram is actually a rhombus, which is kind of cool. But let's go through. Let's figure some stuff out. Because when you're doing a rhombus, you could either do diagonal 1 times diagonal 2 divided by 2, or you can do base times height, whatever your situation tells you. So this right here is dotted. It's not actually part of the rhombus. But you know it's 5 because it's 45, 45, 90. So if that's 5 and that's 5, remember your 45, 90 rules. That's 5 root 2. Since all these sides are the same, they're all 5 root 2. Which means your perimeter is just 5 root 2 plus 5 root 2 plus 5 root 2 plus 5 root 2, which is 20 root 2. Now for your area, I would just do base times height. Your base is 5 root 2, and then your height is 5. It'll be 5 times 5 root 2, which is 25 root 2.